Leetcode problem 2196. Create binary tree from descriptions. So we are giving a 2D integer array descriptions. So the descriptions I equal to parent I, child I is left I. So this means in the first example we are giving this kind of description. So 20 gonna be the parent, and this number 15 gonna be the left child, because this is left is 1. So if it's left is 0 for the second one, so the 20 is the parent, so this 17 gonna be the right child. Yeah, and also we can say that for 50 and 80 it's gonna be the similar. So we need to use this kind of a descriptions array to build a binary tree. But how can we do that? We can solve it by using a dictionary. So for example, we're going to build such kind of dictionary. Let me try to use another color. Yeah, we're going to build such kind of dictionary. So inside of the dictionary, for example, we're going to build all the node with a tree. So the key will be all the values of the node, for example 50, 20 or 80, but the value going to be the tree node. So for example, yeah, we will prepare a dictionary. So 50 with a tree node. Currently we're going to give an empty tree node, so this is just from the beginning. And we can also prepare like 20 with an empty tree node. So I will prepare a circle, because inside we will put some value inside. Yeah, so this is just a tree node. And also for 80, we're going to prepare an empty tree node. And also for 15, 17. Yeah, so why we are doing this? Yeah, because this is easier to execute the iterative function while we are checking each of the tuples, like the parent, child, and the is left. So similarly for 19, we're gonna give an empty tree node. Yeah. So the next step is, if we can put all the values, for example, the value 50, there's going to be a tree node. So for this tree node, if we can use this tree node to build a tree, so finally we just need to return D going to be the dictionary. Yeah, we can just return D50 as our final result. If we find this 50 going to be the tree node. And how can we find the tree node? So while we are checking the descriptions, we should know that like 15, 17, this kind of value is going to be the child. So we're going to put the child inside a set. So while we are traversing all the values, if the value is not inside of the child set, it means this value is going to be the root node. We just need to return the root node with this value. I think that is not so hard, but how can we build this kind of a tree structure? I mean, for each of the value, we're going to have a tree structure. So currently it's going to have a tree node. By default, the value is going to be 0 for each of the tree node. Now we can just check one by one. So for example, this is 20, 15, and 1. So if it is 20, 15, 1, what are we going to do? Because 1 is left child, so it means from 20, we're going to build a left child, and whose value is going to be 15. Yeah. So for this node 20, we're going to prepare a value. While we are checking it, we're going to prepare a value which is going to be 20. So for the value 20, we're going to have a node 20. So after this node 20, at its left side, we're going to have a node 15. Yeah, let me just make it, I think my writing is so bad, but this is 15. Let me make it better. So inside, yeah, maybe I don't want to make a circle. It's difficult to draw a 15 here. Yeah. So for this 20 here gonna be a 15. Now let's check the next. For this 20, the right side we're gonna prepare a 17. So this is gonna be a 17. And the next, for this 50, at the left side it's gonna be a 20. So we cannot take the 20 directly. We cannot build a node as 20 directly there. We just use the k from 20. So we can use this k20. So it means this left side gonna be connected to this 20. So this is our idea. So we will not just prepare a tree node with 20. We just check the k of 20. So we're going to use the k20 to find the left child. It's going to be this node 20 because the 15 and 17 has already built for us. And also for others, if we continue, so for that 15, it's going to be 80. So it's going to be connected to 80. So what about this side? So the right side is going to be connected to 80. Maybe let me make the drawing here. Yeah, so it's going to be connected to 80. So if it's connected to 80, it's going to be connected to its value. It's going to be an empty tree node currently. Yeah, but we're going to prepare the value inside. So inside the value, this value going to be 80. Yeah. Now for the next step, 80 have a value of 19 at the left side. So where is the 19? So this is going to be the 19. So we're going to prepare a value for 19, and for 80 at its left side, we're going to take the k as 19 to take the value. It's going to be this node 19. Yeah, so this is our steps. So by using this kind of step, actually we connected all the k values together automatically. So finally we just need to return d50. It's going to be the final result. Now let's just use this kind of idea to solve the problem. So we're going to prepare a dictionary. It's going to be a default dict. So to solve the problem easier, we just need to put a tree node inside. This means if we are checking a k, if it is not exist, we just put the k value pairs. So the value is going to be a tree node 0, and the k is going to be our current k. Yeah. So now we just check the parent and child and the sign. I'm going to use a sign inside the descriptions. So if sign equals to 1, it means it's going to be from the left side. So the parent, first of all, we're going to find the node, because parent is just a number, and we're going to use this number, for example 20, to find a node. Because the value, the sign is 1, it means from its left side. So the parent dot left is going to be equal to its left side. We're going to find where it is. So we're going to use the k, it's going to be the child. And similarly, if the sign is 0, so the parent dot right is going to be equal to this d child. Yeah, we cannot prepare the tree node directly, otherwise it is unconnected. We have to use the k child. Yeah, but currently we didn't assign any value, so we need to assign the value. So the parent dot val should equal to the parent, and the child dot val should equal to the child. Yeah, because according to this kind of operation, we didn't assign any value. We only assign a reference, but we needed to assign the value to prepare the value for the child and for the parent as well. But we didn't. We also needed to prepare a set. I'm gonna call it a child set. So it's gonna be an empty set. So the child set is gonna be add the child. It's gonna add the child. Yeah. Now I think everything should be okay. We just need to return the node, which the value is 50, like our example. So I'm gonna use our next. Let me think about it. How can we return? Let me use a k node for k node in d dot items. If the k, which is the value, not inside the child set, yes. So finally we're gonna return this dk with the value dk. So we're gonna return this dk. So for k node in d.items, if this k is not inside the child set. So inside the child set, it's gonna be 20, 80, 15, 17, and 19. But 15 is not inside, so we're gonna return this d50. Yeah. Or but we use a next. It means the first. It means it's gonna be the first value. it's gonna be the 50 node. Yeah. Now let me just run it to check. I did something wrong. It should be items. Yeah, as you can see, it works. Yeah, as you can see, it works and it's pretty fast, and the time complexity and space complexity gonna be all in. Or if you didn't know how to write the next, so you're gonna just use dk for k node. Indeed, the items if k is not in child set, but you need to take the first value, so it's gonna be 0. Let me just try. It didn't work. Yeah, because it is a generator. We produced a generator. We have to use the next. We cannot use the index. So otherwise, if you don't like to use the next, you have to check. So let's just write a loop. So for k node, indeed the items, if k not inside. If k not inside d.items, let's just return this dk. I think it's just the same idea. We write it in 3 lines of code, not in 1 line of code, but it's the same idea. Yeah, as you can see, it works. Yeah, but I think the basic idea is that yeah, this time it is much faster. But the basic idea is that we're gonna use this kind of a dictionary, and this is often used in building a graph or in building a tree. For this kind of a data structure, we're going to use the k-value pairs. And for here, we have to use this d-child instead of just a tree node. I think that's all for it. Thank you for watching. See you next time.